Hey, good morning, AP Stats. I know it's a virtual day and you don't want to do anything, but I want to keep our promise for Friday. We got the assembly tomorrow, so please follow along through this lesson. I'm going to go through some problems, and then what you're going to do is take the notes and then try the example problems, and then I'll walk through those. But I'm going to have you prompted to pause the video to do them yourself. And then come Thursday, we're going to move on as if we were in class for these two lessons. Nothing super hard. Nothing that we do in this class individually is super hard. Again, it's just the cumulative effect of doing these little things over time. So make sure you give it your all today. You can message me at any time if you have any specific questions. Just make sure you take a photo of whatever problem you're working on. All right, 715-600-3132. See you tomorrow. So there is a way to find the probability from normal distribution data without using our calculator necessarily. And that's going to become by standardizing the standard deviation and the mean, okay, into a z-score. So if we take a look at this situation, we've got some ponies here that are normally distributed in terms of their weight. We have 213.24 kilograms is the mean and 9.1 kilograms is the standard deviation. What's the probability of selecting a pony greater than 214 or 204.14? So what we would do in our calculator, right? We would normal CDF this, we would put our lower is 204, our upper is 10 to the 99. We'd plug in our mean and standard deviation. But for this situation, what we can do is, if you take a look at what Raymond's dad did, is he found the z-score, right? He did the x value minus the mean divided by standard deviation, got -1. So what you can actually do is you can go ahead and put this into your calculator with the normal CDF, and instead of putting a regular mean and standard deviation, you can go ahead and put the mean is 0 and the standard deviation is 1, and you can do a normal CDF. Okay, so you do normal CDF, our z-score is -1, and then our mean is 0, standard deviation is 1, and then we would go ahead and do our max is 10 to the 99, okay, and then we could find our proportion that way. So there's some things there we'll look at later. All right, so here are some advantages of go ahead and finding the z-scores instead of just using normal CDF in our calculators. So we have this problem. We have this blue peafowl and Congo peafowl, whatever in the Congo. All right, so we've got normal distribution. It says if the 21st percentile is 2.539 pounds and the 83rd percentile is 3.2027 pounds, find the mean and standard deviation. Okay, there's going to be a lot going on here in terms of mathematically. Now, in general, this problem is not terribly difficult, but what we do need to do is we need to find what is the general z-score of a 21st percentile and what is the z-score of the 83rd percentile. Okay, again, we don't know the mean and the standard deviation. Okay, so that's key. So what we're going to do is we're actually going to go to our calculator and make sure you write these notes down because you're going to have to do one very similar. And we're going to have to inverse norm this situation, okay? So if we have the 21st percentile, then we're going to do the inverse norm of 0.21, and then we're just going to leave our standard deviation and our mean as standardized, so 0, 1, and we want to go left. Remember, percentile is what data is at the 21st percentile and less. Okay, so if you put that in the calculator, we get -0.81. That means the 21st percentile is -0.81 standard deviations away from the mean, or that is the z-score. What I'm going to do is I'm going to go ahead and do that same problem with the 83rd percentile. So go ahead, plug this in your calculator. 0.83. My standard deviation is 1, my mean is 0, and I want to go to the left. I end up getting a positive z-score because this is obviously going to be to the right of the mean. All right, so that z-score is 0.95. So it's going to get a little crowded here with the amount of room I have to write, so just bear with me. So what I'm going to do is I'm going to go ahead and kind of draw what these curves look like. With your homework and with a lot of these, you have to draw the normal curve. So this right here would indicate the 21st percentile. When I go ahead and I change colors to the orange, that would be what the 83rd percentile would look like. All right. So let's go ahead and set up our z-score equations. Now this does get a little long, I understand that, but you need to get every one of these steps because when you do it on your own, obviously you need to see it. So for the z-score, we put our x value minus the mean divided by standard deviation. Again, we don't know mean or standard deviation, but we do know that the z-score is negative 0.81, okay? So what I'm going to do is I'm going to go ahead and manipulate this equation. So I'm going to multiply both sides by the standard deviation, sigma, okay? So I'm going to get 2.5389. Oh, here we go. I'm trying to erase here. 2.5389 minus, there it is, minus mu, there we go, equals negative 0.81 sigma. All right. So now I'm going to go ahead and just solve for mu. So don't get confused. What I do is I add the mu to the other side so it becomes positive, and then I add the 0.81 sigma to the left side so that becomes positive. So I get that. So I get mu equals 2.5389 plus 81 sigma. All right, now I got to do the same thing over here for the 83rd percentile. If at this point you just skip to the end, I totally get it. Okay, so we're going to do 3.2027 because that was the 83rd percentile minus mu divided by sigma equals our z-score. So we're going to go ahead and multiply both sides by sigma. So I get 3.2027 minus mu equals 0.95 sigma. All right, I'm going to do the same thing that I did on the other side. I'm going to add the mu to make it positive. I'm going to subtract the 0.95 sigma so that I can have both equations equal to mu. Now I just have a systems of equations. What's nice about this system of equation is they are both equal to mu. Now, I'm going to run out of room here, so bear with me. So I'm going to write my 2.5389 plus 0.81 sigma equals 3.2027 minus 0.9 sigma. And I'm going to go ahead and I'm going to solve for sigma. And then I'm going to go ahead and plug that sigma into one of my equations and solve for the mean. Okay, so at this point I'm going to speed it up and I'm going to be done for this. All right, here we go. We're looking at chapter 6. So, what's a discrete random variable? Okay, so discrete is when they're counting numbers, no decimals. Take a look at what you get. At A, C, D, E for your answer, then you, my friend, are correct. The reason why being discrete is so important is because we're going to deal with situations with probability. And these X values are discrete because each outcome is 2, 4, or 5, right? So I have no decimals. Each probability is accounted for as a whole number. Okay, so what we want to do is we want to find the expected value of this spinner, right? So if I spin this, right, depending on how many points I get, depends on the probability of getting each point, okay? So we have to realize that expected value is also the mean of the data. So if it's like, what is the mean of this information? That is the expected value. Okay, so the expected value is the sum, okay, of the values that you get for each of your outcomes. Okay, so that'd be the 2, the 4, the 5, times each probability of getting that outcome. Okay, so not rocket science here. So the expected value of this situation is just going to be 2 times 0.3 plus 4 times 0.2 plus 5 times 0.5. So we end up getting a expected value of 3.9. So this is a legit concern. How could the expected value be 3.9 when that's not one of the probabilities? Well, 3.9 is what we would expect to get if we did this over and over and over and over and over again. Like our average score, if we add it all together and divided by, whatever turns we took, we'd get 3.9. And then should we do X bar or mu? This is the entire population, so mu. All right, now that we calculated mean, which is expected value, we got to find the standard deviation. In order to find the standard deviation, what we have to do is we have to find the variance. So just a reminder that expected value is the mean, and the variance is how far each value is from the mean squared. Okay, so just like it says, variance is the squared distance from the mean. So in order to find our variance, we have to go ahead and we have to find the distance from the mean. So for 0.3, the distance from the mean is, well, you got to have a value of 2, and then the mean is 3.9, so that's negative 1.9. We square that and we times it by the probability of getting that value. We do that for 2, 4, and 5, and then we go ahead and add up all those values. We end up getting 1.69. So what we do is we go ahead and we square root that to get the standard deviation, which is 1.3. All right, here we go. So we're going to try this without necessarily just doing normal CDF in our calculator. We're going to find the z-score. So we're going to realize that the mean and standard deviation are listed. We're going to see our x value. So we're going to go ahead and translate that to a z-score. So we take our x value minus our mean divided by our standard deviation, and we end up getting a z-score as negative 1.49. So if we take a standardized look at our probability density curve, it looks like that, and we would have to draw that. And remember, it says greater than, okay, in the air sample greater than. So I'm going to go ahead and do normal CDF using our standardized information, and we end up getting, look at this notation here, make sure you do that, 0.932. All right, well, I'm going to guess that some of you did not pause and you just used the YouTube video. The downfall is now you have all the answers. So if we take a look at this, we can see that we have to find the z-score of the 5th percentile and the z-score of the 60th percentile, which is listed above, negative 1.6449 and 0.2533. So we're going to go ahead and set up the z-score with the unknown average mu and the unknown standard deviation set equal to our z-score for both of them. We're going to go ahead and solve each equation for mu. And then what that allows us to do, it allows us then to go ahead and put each equation equal to each other since they both equal mu and solve the system of equations. But here we go for this problem. We're going to go ahead and find the expected value. We're going to draw the probability chart. We're going to find the variance. And we're going to find the standard deviation. So if we have a value of 4, which is heads, it's a 50% chance. Same thing with 8 for tails. So the expected value is going to be the score you get times the probability of getting that score, and you add them up. Okay. Now variance, that's going to equal the distance your score is from the expected score. So 4 is -2 away from 6. Okay, we're going to square that, and then we're going to multiply it by the probability of getting that value. You have to memorize this process because we're going to be doing this a lot with all different sorts of sets of information. So our variance is 4 here, so that means our standard deviation is just going to be the square root of our variance. Okay, so the standard deviation here ends up being 2. Easy peasy, lemon squeezy.